So our next speaker is Heike Leitte. Heike is now assistant professor for computer graphics and visualization at the University of Heidelberg. And her research interests cover many topics such as flow viz, topology, and biology. But she has also spent a significant amount of time on validation of visualization, and in particular on how one might be able to automate the process of validation. And so we're very happy to have her here, and I hope she will tell us more about it now.
Thank you, Britta, and yeah, thank you for organizing this workshop. It's really great to see this work going on. And yeah, Paul asked me, I don't know, like 2 weeks ago about the title for my talk. I didn't have the slides, so I had to come up with a title given the direction. The original one is visual correctness, or how do we measure the quality of our visualization. And while doing the slides, I realized that it's far too much stuff to be covered in one talk, especially in 15 minutes. So it's an either or, and I'll do the second part. So it's only quality and visualization, and we will leave out the correctness. And well, you all came here to this session on quality analysis and the other V's. And yeah, why should we care it, or why should we bother ourselves with validating the visualization? We could just propose our methods, write the papers, drop them out, and then let the user decide. So they're gonna pick whatever they like, and then we just see which methods are accepted best. The problem with this approach is that when you try to find a method, it's sometimes really difficult. So in Heidelberg, I work together with biologists, and they're amazing. So they have problems they can't solve so far, so they realize they need visualization, but at the moment they don't have the tools to help them with their problems. So they start coding on their own, try to find papers, implement them. But the problem is when you look under that and try to find something, you end up with problems like that. So I did a Google Scholar search for some basic topics, for fundamental approaches. If you look for line integral convolution, you end up with 150,000 papers. For volume rendering, it's almost 1 million papers, and focus and context, it's close to over 3 million papers. So if you try to find a good one, yeah, you have to check all this. So maybe you go to some colleague and ask, okay, give me some journals that might be interesting that address this specific problem, and hope to lower the numbers of the papers you get. So I did an IEEE search in CGNA and TPCG, just because they have an easy interface, so you can take any journal. And I still ended up with 100 papers for LIC, 3,000 papers for volume rendering, and 2,500 papers for focus and context. So it's still a huge number of papers that you would have to check, and you get a grasp on this. And so I think we have to provide them with tools to compare the different techniques to help them find the best one for their need. And we also need it for ourselves, because when we write a paper, we got to compare to the state of the art. And for example, if we take LIC, there's a nice paper by Zhangping Yu, I'm not sure how to pronounce it, I'm sorry. And he did a nice survey on the different LIC techniques that are out there currently. And you end up with, I don't know, 15 techniques or so. And you write a paper and think you got a nice improvement for LIC, you should somehow compare to the other techniques that are out there. And so you have to standard LIC, fast LIC, pro LIC, oriental LIC, enhanced LIC, and some more. And from some of them you can, by the name, sort of guess in which directions they go, and there are others where you just don't have an idea. And just comparing each and everything is really difficult. And the next problem is we don't know how to compare. I know I'm lost, I'm not sure what's on the next slide, I'm sorry. Genau. So you wonder, okay, you got this bunch of methods, don't know how to compare, don't know what to compare, and so you might have a look at some overview works, like you can have a look at textbooks, at survey stars, or the paper itself. And there are always some problems. So textbooks, for example, only cover like ground material. So you get the basic algorithms, but if you get knocking at your latest research algorithm, it won't have the adequate other techniques in textbooks. So surveys and stars are usually have much newer work, but the problem is there are not many out there. So they don't cover too many topics, and the same problem, so they get outdated and are not often updated. So although there are a lot of stars, for example, state-of-the-art reports in flow visualization, they sort of become dated by now. So same problem like with textbooks, the methods get old and not always cover the latest research. Then if you were able to sort of haven't spoken English for some time, so it's difficult. If you found some methods that are relevant and that are close to your work, you might look in the papers and try to compare to them and see what they wrote about comparing different techniques. And then you see that the problems is that, well, the authors wanted to get their papers published, so they don't tell everything that they found. So they, well, we all probably do, hide some details where the methods fail. And so it's sort of biased what you find in the papers. So you need some sort of external review that compares different methods. And then we have to discuss the way. So now we first have to find what we need to compare, and the second step then is how do we compare. So the first step is, what to compare is you might have varieties of the same technique as we have with the Lick approach. So there are like 15, 20 different techniques that you want to compare. And there are different parameter settings. So how do we compare it if you have like 5 parameters? Do we only take the best visualization that we can get with each technique, or do we analyze the whole bandwidth and how they work in different settings? Then you might be interested in just, can I close this? You might be just interested in, for example, visualizing multivariate data. And then you don't have the one specific technique, but there are multiple techniques. So how do you compare techniques that have different angles of attacking the problem, different focus on the problem, and you can't run it on the same data and get images you can easily compare. And the last thing that might be relevant is technical requirements. So some methods need a special graphics card or special hardware, they only run on clusters, which makes the whole comparison difficult again. So this is the first, there will be 3 steps or problems in analyzing the quality of a visualization. And the first one is, how do you find appropriate methods to compare with? The second problem is, then if you found techniques you want to compare to, how do we actually compare them to each other? In most papers we have 3 steps that can be compared. The first one is how difficult is it to implement a method. The next one is the runtime costs, and the last is you actually compare the results. So implementation costs is often pretty difficult to judge. As Paul said, for example, not always all necessary detail is given, so you don't know how difficult it will be to compare. And even if you got pseudocode, it might be really much more work to implement it, because one line can be 1,000 lines of code. Then runtime measurements are usually given, so that's especially in Cybis, you always get, or most of the time get measurements on how long does the method take, how much memory does it take. The problem here is, again, how to compare, that's fairly okay. So the last part, which is the most tricky one, is how do we compare the results. So if you run different methods on the same data set, there are different ways to compare the results. You can just look at the images and say, yeah, well, I like A better than B. You can use, for example, user studies, give the users some tasks to do and look where do they perform better. And the last one is some sort of precision correctness. How well does the visualization, for example, represent the data? So if we look at this second bit chunk after having selected some methods, we want to sort of compare them. And all of these things fall into the category of quality of visualization, and that's where my talk is going to focus on. And the big question is, do we, knowns and unknowns, do we tackle all the different angles of quality in visualization, or is it a too limited view that we can? So I had a look at different textbooks, and I found the approach by David Garvin from economics quite interesting, who looks at 5 different aspects of quality. Before we go to this aspect of quality, I have to hurry up. Here's are the definitions of quality. There are 2 major distinctions. One is on the one hand side, you can say quality is just something that defines a subject, which is neutral, or you can have it some sort of superiority, which I will use, or excellence. And if you use this notion of excellence, finding a method that is better than the other one, there are 5 angles which I find quite interesting that we might take to look at the different at quality. So the first one is relative or transcendent quality. That's what most people assume is quality. It's, for example, like judging something like beauty. So you can't really quantify, it's just you think this one is better than the other one. The next measure is product-based quality. It's things you can measure. So like if you produce a car and it has to fulfill certain requirements, and you can easily measure them. On the contrary, there's the user-based quality. So how does the user experience the car? What do they feel is the quality like of this car? Which can be, so you can have a perfect car from an engineering side, but the users just don't like it because it doesn't work, the viewing is not correct or something like that. The fourth aspect, let's say the manufacturing-based quality, says something about you predefine certain requirements that have to be fulfilled, and then you look in the end if they are really fulfilled. And the fifth one is value-based quality. It's again the user notion is how much do you get for the money you spend. So I think I just skipped this, or maybe go back later to this one. So if we look at these 5 aspects of quality and how we meet them in visualization, so I try to sort them from left to right. Questions on quality you can answer with user studies. On the left-hand side or on the right-hand side, things you can sort of measure automatically. So we got this sort of beauty notion of quality that you just, and that's something you surely need a user study if you want to figure out if someone thinks a method is good. You should just ask them. There are also automatic techniques that try to capture this, like automatic measures for aesthetics or visual effectiveness. And on the contrary, there are these measurable quantities that we can, where we can create algorithms to test them. And there's some things in between, like this user-based qualities. So how well does the algorithm fulfill a certain task? It's more user study type, but we try to emulate this using automatic algorithms. And the pre-quality, where we measure or we specify certain needs and look how well we map them, we can usually capture them using timings or memory footprint. Same for value-based quality. So how do we feel? Do we get enough for the amount of time it took us to implement the algorithm? There are automatic approaches, but I think it's easier to get this with a user study to ask someone, do you think it was worth the effort of implementing all this? So, sorry, okay, exactly. So this is just a way of looking at quality. So different angles, seeing, measuring different aspects of quality or different views on quality. And what they have in common is that in the end you need to measure something. Even if you do a user study, you have to ask the user questions, and you need something that you can count and can compare, otherwise it doesn't make sense to you, or you can't evaluate it. So David Garvin again, he also had the nice notion of 8 dimensions of quality, which I think is very good. It's what he mentions is performance, features, reliability, conformance, durability, serviceability, aesthetics, and perceived quality. And although these were designed for economic goods, they, I think, fit very well also for software, for visualization approaches. So for performance, we can easily measure how long does the algorithm take, how much memory does it take to run the method. We can look at the different features, So is it just a method for one particular problem, or do you have a larger range of problems? Sorry, I'm hurrying. Reliability, there's the problem of uncertainty. So how well this algorithm work for not just one type of data set that the authors presented in the paper, but a larger range of techniques. Conformance is how well does it meet the needs that we defined. I think that's usually done. Durability is one thing. Does it only work right now, or is it an algorithm that has a long-term perspective? Will we use it in 10 years, or is it only designed for current techniques? Serviceability doesn't really fit, but we can sort of switch it a bit. So let me say, so how easy is it to use the algorithm? Are there easy estimates for the parameters? How easy is it for the user to get the thing done? Aesthetics, do you like the algorithm? Do you not? What comes out? Perfectly translate to visualization. And then there's always the perceived quality. And here we come to the third part, the biggest problem in the whole quality pipeline is the user. So you can have the perfect algorithm, and you find that it works perfectly, and then there comes the user and he says, well, I just don't like it. And even if it's only the color scheme, you never know. There are differences in users, and we got to cope with them. So there are different visualization literacies, preferences and habits in different communities. And then what Robert already said, there's the question, what's in the data, what is rendered, and what does the user get in the end. So, and now I come, sorry for taking too long. My last slide. Conclusion, but again, I end with a lot of questions. What I would like to have is, making my life easier is the first part, to get a better way on quality and the three things, how to compare things, how to find things to compare, how to compare, and then getting the user problem in there as well. The first part is how benchmark data sets would be nice, so that if I have a new algorithm, I can run it on some benchmark data set and say, okay, that's what I do. More survey stars, taxonomies, to figure out what do I have to compare. A visualization textbook would be great, not only for doing this sort of work, but also for giving courses. So there are some books out there, but would be nice to get some more, especially in Cybers. And then there comes a bunch of questions. What I would like to see in the future is questions. So how much EuroRVVV do we need in our papers? Then the big questions, where do we have to use user studies? What can be done without automatic techniques? Then if we do user studies, how do we train our students properly? And for the automatic techniques, the big questions, which questions do they actually answer? So ending with a lot of questions, and a thank you. And I hope for more questions.
Okay, so any questions? Okay, if not, then I'll start. You were talking about comparing, but just based on reading the paper, for example, reading what timings are, or looking at the pictures or something like that. But how valid do you think that is? If actually you never saw the software that other people used, how valid is such a comparison?
Yeah, that's the problem, that you can't really compare. So everybody, most of us, only present the nice results in the papers, and you leave out the...
So that's a point for reproducibility, right?
Yes, it would be great to get this information in, but you always get the problem, you want your papers published, and if you present the drawbacks, well, that's a good reason to reject the paper. So I don't know how to get this right. So this is one thing for the entire community. So I think it's good to have it for an open discussion, maybe for the panel later on. So how can we make ourselves write these things in the papers?
So you mean people don't publish their software because it's then subject to criticism, or it might be subject to criticism? That's one of the reasons.
With the software, I'm not sure, but that's why people don't write in their papers, and in this case, the software fails, or the algorithm fails. Because, then the reviewer says, well, it failed. So that's, why people might tend to not write all the details. That might be interesting for someone who wants to reproduce. So I think for me, it's absolutely okay if you say that in these cases it works, and then it's fine, then I know.
Okay. So, Any further questions? Yeah.
Thorsten Muller, Simon Fraser University. I have a question and a comment. My question first is going back to your numbers that you presented in the very beginning about papers on LIC and volume rendering and focus and contact.
Yeah.
Do I understand that correctly that there's 3,300 papers just in CGNA and TBCG on volume
No,
rendering?
it's Google Scholar. Well, no, it's the first numbers are Google Scholar. So I just typed in focus and context. And these are unchecked the first couple of pages, and it was.
What's the second number?
The second number is the search in CGNA and TBCG. So there are 2,500 papers that have these terms in the paper. It's not necessarily that they really focus on an algorithm for focus and context visualization, but it might be somewhere in the paper that they have a LIC technique and say, well, you should look at focus and context methods. I didn't check all of them. It's
okay.
2,500.
It just seems strange because 3,300 papers for volume rendering, that means the last 10 years every single paper was a volume rendering.
It was just to I think we all know the problem. I wanted to have some figures to print on the slide because there are a bunch of many techniques of volume rendering. So I always have the problem. I want to implement some nice volume rendering. Where do you get started? I think volume rendering is a nice example because there are so many papers at this each year. Which one to pick? How do you know which one is best? Is there a best one? And so.
Yeah, I wrote one. No, just kidding.
Can I get the code?
But the comment, the serious comment that I had is what helps me in terms of understanding how to evaluate visualization research. I found Tamara's nested model quite helpful in breaking things up into what stage of the visualization pipeline am I trying to make a contribution to. Is you're familiar with
maybe I read some. I should read some more.
It's a great paper.
Yeah, she has many great papers. That's a problem. So the homework is excellent. So, but thank you.
Alan Sanderson from Steve Student of Utah. Something where we as a community could come together on in terms of doing analysis is, especially in the flow field visualization, and there's lots of techniques for doing flow viz. And if we take a parallel to like the medical image community, with any new techniques that come out, basic papers get rejected if they do not do a comparison with other techniques. They just don't get past the review process at all. And that's really a sign of maturity in their field, where they've said, we've got enough techniques doing this. If you're going to introduce something new, you really do need to compare it before we're even going to look at publishing it. Flow is definitely one area we could start doing something like that. The question is whether we as a community want to be, that hard-nosed in doing that. To me, when I see people with flow, and there aren't any comparisons, I usually ding it pretty hard in terms of the review. But not everybody wants to do that. So that's something for our community to think about.
Yeah, thank you. Yeah, good point. The problem is also if we don't deliver code, it's really hard to reproduce the work, and it takes ages if you have a PhD and tell them, okay, please re-implement the 3 other papers that are out there closest.
That's true, but for instance, like Greg Turk does a very good job of getting his code out there on some of the early stuff, and I guess I look at it as we as researchers, if I put a technique out there and I don't have enough information that somebody else can reproduce it, and it gets into a paper that's poorly reproduced, who does that reflect on, me or the other person?
Right.
So it kind of behooves us to make sure our techniques are documented well enough, and to me sharing code at this point is not any big deal because it makes my stuff look better to a certain degree if it gets out there.
Excellent.
Okay, so we're a little bit over time, so I think we should thank the speaker again.
Thank you.